Alright, today we're going to be looking at compound probability in the form of Venn diagrams. Again, we're going to be looking at complements, intersections, and unions. So first off, a complement of a set is all elements that are not in that set. So it's basically the opposite of what you see. So for set A, its complement is A with this little apostrophe right here. So that little apostrophe means not A. So if we look at our Venn diagram right here, everything that's not A is what's shaded in. So that would be the complement of A. A is everything that's in that white circle. So everything that's shaded, again, is not A. We're going to look at the difference between intersections and unions. So an intersection of both A and B is the set of elements that are in both A and B. So where the two sets meet. The example of this is below. The Venn diagram shows the intersection of A and B. And again, it's where the two sets meet, and here they meet in the middle. The intersection of A and B is written as A with kind of a big lowercase n and then B. So that lowercase n means intersection. The union of A and B is the set of elements that are in A or B or both. So the union of A and B, again, it's going to be A and then like a lower or an uppercase U and then B. So U means union. The union of A and B is everything that's in A, everything that's in B, or everything that's in both. So it's that entire set of circles. That would be the union of A and B. All right, we're going to look at some examples of unions and intersections and complements. So, on the Venn diagram, we're going to shade the regions. We have example 1, A intersect complement of B. So first what I'm going to do is I'm going to draw this out. I'm going to draw my circles. I have A and B. That's A, that's B. Great. Okay. So I have A intersects not B. Okay, so first off, I'm just going to fill in my A. A is this circle that's right here. And then I'm going to fill in not B. Not B is everything except for what's in here. So that's going to be all of this, because that's not B. And also everything that's outside of the circle includes what's inside of A. So this is also not B. So where the two things intersect is where, where the yellow meets the red. So in this case, our intersection of A and not B is going to be right there. Okay, again with example 2, I have A union of not B. So again, we're going to start by filling in A, because we know where that is. That's just the circle that has A in it. And then not B, again, is everything that surrounds B. Including what's inside of A. And because it's a union, that means everything that is in A or not B or both. So in this case, everything that we just shaded, we're going to keep. And this would leave us with the intersection, or pardon me, the union of A, not B. Okay, example 3. Complement of A intersects with B. So this is kind of like example 1, except now we're looking at everything that is not A. So things that are not A would be obviously B, because B is not A. And it'd be everything outside. And then where this intersects with B, be here. So our our intersection of not A, or complement A and B, is going to be here. So that's everything that is not A, but is also B. Example 4. Okay. Pardon me. Example 4, we're looking at everything that is not A and where that intersects with everything that is not B. So let's just start with things that are not A. That's going to be in green. So everything that is not A is getting shaded in green. Oh, Lord. Okay, so I'm not filling in that middle section because the middle section is not A. Okay, so everything that's in green is everything that is not A. Now we're going to shade everything that is not B in red, and where the two colors line up is going to be our intersection. So everything that is not B. Okay, so where the two colors line up is our intersection, and where they line up is all around the outside. And that would be the intersection of not A, not B. On the next page, it says use the Venn diagram to shade the following. So for each of these examples, we're going to use the exact same Venn diagram. And again, it doesn't have to be perfect, you just have to get the idea down. There's two circles that are not touching. One's labeled A, one's labeled B. Okay, but it doesn't have to be perfect. Oops. Okay. All right, so for part A is things that are not B. So basically, we're going to fill in everything except the circle that's labeled B, because that would be the complement. So we're going to fill in all of this box, and we're also going to fill in our little A circle, because that is not B. Boom, there we go. That is everything that is not B. Part B is going to be the union between A and B. So everywhere A and B intersect. So union again means everything that is A or everything that is B or both. Well, they're not both. It's just A and B. They don't cross, so there's no place where we could say it's both. So this is where we're at. Everything that is A or everything that is B. Part C, it asks for the complement of the intersection of A and B. So where A intersects B, well, if you notice, I'm just going to do this in blue, they don't intersect. They don't cross. So we have to think about this. They don't cross, so there's nothing to fill in. So if they don't cross, then I can't fill anything in. So what I would have to realize is I have something that's blank, and I'm being asked to do the opposite of that. So everything that is not blank. So we're basically going to fill this whole thing in. That would be the complement of where A intersects B. Okay, so we're going to move on to the next set of examples. Again, use the Venn diagram to shade the following. So we're going to use this Venn diagram for all three of these examples. I'm just going to go ahead and fill all of those in. Okay, so we have A intersects B intersects C. So intersections. Again, intersections means the region that is both of those things. So let's look at this. We're going to start with, where does A intersect B? Okay, well, A intersects B here. Well, where does B intersect C? Oh, right there. But A is also intersecting where B intersects C, which is there. So our answer is going to be where all three of those colors overlap each other, which is going to be in the middle. And you can just fill that in black, or just a darker shade of everything. Okay. So we're going to move on to part B. Okay. So we're looking at A union B intersecting C. Now I'm going to use order of operations here, and I'm just going to work with what's inside the parentheses first. So where does B intersect C? Okay, meaning where do B and C cross? Okay, so B and C cross here. They also cross in the middle, so I'm going to fill that in as well. So there's that. But then I have this A union, which means I need to fill in all of A. And I need to take into account that I also have to have the union of B or C. So that is going to be how that Venn diagram fills out. Because again, union is going to be A, or where B intersects C, or both. Last one. Okay. So, this is a bunch of intersections. Intersections means everything that is in that region, or everything that is in both of those regions, or all three of those regions in this case. So this is kind of going to be a lot. We're going to use different colors here. I'm going to shade A in blue. Okay, so everything that is not A. So that's the outside of the box. It's also part of B and part of C, as long as we don't cross A at all. Okay, so that's everything that's not A. Everything that's not B is going to be in green. So again, the box itself. It's also going to be C, as long as it doesn't touch B. And it's also going to be A, as long as it doesn't touch B. Finally, everything that is not C will be in red. So everything that's outside the box, as well as what's inside of A, and what's inside of B, as long as it does not touch C. So, where do all three of those colors overlap? Well, the only place they all overlap is inside the box, but not in the circles. That's where all three of these colors overlap, so that's going to be where everything intersects. And that's going to be our answer. All right. That was compound probability when working with Venn diagrams, intersections, and unions.